Okay, Paul here, and today on the bench I have this fan that was sent in. Don't know anything about it. It has a run capacitor. I think might be a stock capacitor, but I think it's a run capacitor because it's only 3.3 microfarad. That should be a run capacitor. Run capacitor. Stock capacitor is usually 100 microfarads and above. Or 50 and above, something like that. Doesn't have any label on it, and it's part of a box fan, and the customer just sent me the motor, which to help with shipping. And the motor turns freely. I'm thinking this capacitor might be dead, and it looks pretty old, but we'll check it out right now and see what we find out. So bear with me as I'll hook up some leads to my meter and we'll check out and see what's going on with it. Okay, I hooked up my meter here and got one cable connected. Put some jumper cables on so I can use the camera. So we put this on. Okay, microfarad scale, or nanofarad in this case. And we'll see what we get. Oh, okay, it's still climbing. Well, the capacitor is fine. It's 3.5, and it's a 3.3, and that means it's really good, actually. No problem there. So I can hook it back up, and we can bring it up slowly on the variac with a current limiting bulb and see if we get any life out of this motor. And we'll see what happens. So let me go ahead and connect that wire back up, put the wire cap back on, and it's just got a suicide plug here, so we'll hook up a suicide cord for it and plug it in, and we'll be off and running. Be right back. Okay, the motor turns freely. I've got my current limiting bulb on up there, and we'll bring this up to a reading we can read. All right, I'm at 40 volts, drawing 10 milliamps. So, a little bit of resistance there. Let's try a little more voltage. Bring it up to 57, 61 volts. Okay, light bulb's still out. That's a good thing. And current, no current. So, where's that switch? There we go. Now it's on. And we got a little bit of light. It's 70 volts. Not wanting to turn. It's trying to turn. Let's bring it up a little more. Let's see what we got for current. Not quite enough to turn the meter on. All right, 670 milliamps. That should be. It's turning, but it's sluggish. The voltage is dropping, so most of the voltage is across my light. Bring it up a little more. I'm drawing 680 milliamps, but most of that's probably my current limiting bulb. Kick it out and make it spin. There we go. And we're drawing a little over an amp. So now we're down to 560 milliamps. We got it kicked off anyway. I'm going to let it run a little bit, keep it on my current limiting bulb. It's not getting warm. Let's put a couple of drops of oil in there and see if the current drops any. Let that work its way in there. I hear something in there. Interesting. The head wire looks okay. I'm going to turn it off and put a little oil on the other side and see if we can get that current down from 560 milliamps. Okay, but it's running, so that's a start. This thing here, I don't know exactly what it is. I think it's some kind of heat sensor that breaks the circuit if it gets hot. It's a mica panel, and it's bolted right across the mica with that piece of steel that's bolted right through the metal. If that mica is shorted, it's probably supposed to be connected together. I need to check the resistance across that and see if it's a connection. If it is, then it's possible that that's just a heat relay that would disconnect, or supposed to disconnect if it gets hot, but it's not even warm, so I don't think that's a problem unless that's not supposed to be a dead short, and it is, or something like that. But we need to figure out what's going on there. Like I say, the capacitor is not hot, so it is leaking a little bit, but it's an AC capacitor and it's non-polarized, so it shouldn't matter. It has a good reading. I've seen one of these jokers explode, so be careful of it. But let me go ahead and oil that a little more, and then we'll see what we got. Okay, that didn't make much difference. There's a lot of debris in here. I pulled some out with my pliers and long nose, and it's just a lot of buildup of junk. So I'm going to try to get the motor shell apart and the housing and see if we can clean it out a little bit. That'll definitely help it, and then go from there. There was no oil at all on the shaft here. Of course, I just oiled it. It would take a little bit of time to seep through and get into that bushing, but I'll just oil that. This motor definitely got hot. You can see all the covering on the wire has been exposed. I don't know if the armature is shorted, but it got hot. I don't know. It's hard to say. So I'm still taking it out. I take these two screws out, and the stator should come out. There's the rotor. Nice rotor. I like the way they enameled that. It's just really cool looking. Yeah, definitely got some problem there with oil. Now the oil did get through here, but not very good. As you can see there, a little bit got in. But we'll clean that up and re-oil it. I'm more concerned with the stator and the condition of the stator than I am the rotor. The rotor looks fine. There's a little washer, looks like, on the short end there. Well, maybe it's just the way it's cut. Okay. See, but pieces of the insulation on this, it's all griddle, just coming right off, just fell off. So it got hot, no doubt about that. Whether or not it's shorted remains to be seen, but once we pull it out and clean it, check the head wires on it and see what the resistance is. Let's see if we can get this one broken free. Oh yeah, well, at least they come out loose. Easy. I'm assuming that we'll get that out. I don't know. It's like two ways this rotor is screwed in. One here, and it looks like one from the back. I mean the stator, sorry. Okay, that's those. And you can see where they got hot. They need to be cleaned. And then the rest, these two screws here. And they are tight. So I'll have to figure that out. I might just blow this stuff out of here. This side of the coil doesn't look so bad. This side got really hot. But let me work on it, see if I can get this out of here. And we can go ahead and check the resistance on the head wires. Let's see, how many wires does this have? It has 3. So might as well document what we got. We got a red wire, or a copper colored wire, going to one side of the capacitor. And we've got a green wire going to the other side of the capacitor, along with a green wire that goes to this mica thing. This measures 28 ohms, and I'm thinking sandwiched in there is some kind of resistor. I can see something, but you know, mica over years deteriorates, and you can see this one already has. So, and it got hot. Had some kind of number on it. But it got hot, and so we need to check that thing out. Okay, but anyway, so the green wire goes to the capacitor along with a green wire that is capped to the switch and goes to another cap and goes to the switch. Additionally, let's see, yeah, that goes there. So we have that. And then there's another, let's see, there's a yellow wire coming from the motor, which goes directly to the line cord, so that makes sense, to one side of the line cord. The other side of the line cord goes to the other side of the switch, comes back from the switch, and connects to the other side of the wire that goes to this resistor, which is probably a current limiting resistor, and then it goes to the capacitor again. So let me go ahead and pull these 3 caps off, and we'll check the resistance on the stator and see what we're getting for stator coil resistance, and then I'll continue working on trying to either get that out or blow it out really good with the compressor. So I'll be right back. Okay, went ahead and labeled the wires coming from the stator as A and B, and where they connect. That's A1, I mean AB, A2, this is A1, so the A's go together, B's go together, that kind of deal. I didn't mark the C wire because it's 3 wires together, and that's going to just be fine. I just had to disconnect 2 to get accurate readings. So we will go from A to B first and see what we get for resistance. If my alligator clip will cooperate. Okay, here's B, and here's A. Okay, we go to ohm scale, and we're reading 87. Well, let's let it kind of settle a little. All right, we'll call that 87.2. I didn't zero out the meter, but that really doesn't matter because we're just doing relative comparison. So we'll say it's 87 ohms. Okay, so that's 87 ohms from A to B. Now we'll go from A to C. And C is at 3 wires together here. And we've got 107. So 107, we'll call it 107. And we'll go B to C. So we'll come off of the A and go back to B. And B to C we have 21. Okay, well that's good. So that tells us the windings. And what we have is A to C is the one that's across the run capacitor. So we have the motor here. And we've got 3 wires coming out. The one that goes directly to the line cord is the B wire. So we'll call this one A, this one B, and this one, we'll jump over the B wire, C. Okay, and so A and C go across the capacitor. So we have our capacitor here. B goes directly to the line cord. The other side of the line cord comes out and it connects to the switch. So it connects to the center pole. It's actually a 3-speed switch. So off, 1 and 2, or off, 1 and 2, which would be low and high or high and low. I didn't really check that, and it really doesn't matter. Okay. All right, so it comes to the switch. From the switch, that's this line cord that's green. From the switch, we have one of those two, and I'm going to call it number 2 and go counterclockwise around here. I mean clockwise. So number 2 connects to the capacitor, to the C side of the capacitor. So number 2 comes up here and connects to the C side of the capacitor. Yeah, because I'm looking at the bottom. So this would be 2 here. Yes, and that connects to the C side of the capacitor. It also connects to that funky resistor thing. So up here we will put the funky resistor thing. Okay, the other side of the funky resistor thing goes to, oh here, goes to number 3, or what we would call number 1 here on the switch. So that goes to the other side of that resistor. Not the best schematic, but you get the idea. Okay, and that's off. So we have the hot lead coming into the motor. We have on low, it goes through the resistor and goes to across the motor. So that's low, obviously. That's a resistor, speed resistor. That's what's in that mica thing, 28 ohms. That's low. 2 is high. Yeah, 2 is high, and it goes to C, which is the other line going into the motor. And the A of the motor just goes to the capacitor. That's the run coil. And it should be a run capacitor, so it'd be a run coil to basically get it started. So there is a possibility that that capacitor is bad, but I'm thinking it's mostly the dirt and stuff in here, so I'm going to clean it out. I'm going to connect it back the way it was, put the caps back on. By the way, they're all porcelain caps and porcelain insulators. This is a very old fan. I don't know anything about it. It doesn't have any markings on the case or anything. So we don't know, but we're going to clean it out, get it all clean, get all that debris out of there, because anything that makes the motor run hot is going to make it draw current. When it draws current, it's going to overheat the coil and make it run sluggish, and that draws more dust, and it's an accumulative thing until it finally does this. It overheats the coil. So judging by these resistances, I think we're okay. I don't think the state is bad or shorted, but it did get hot. And of course, I will re-shellac it. I'll take off as much of that cruddy stuff as I can that just flakes off. I don't want to scrape the coil. I just want to knock off the loose stuff. See, most of it is loose. You see, it comes right off. So I'll brush it off, and then after I get it off, I'll put shellac on there to make sure that those windings do not short out, and then put it back in its case, and it should be, the current rating should be down. Now this 28 ohm resistor, I don't know what that's supposed to be. It measures 28 ohms. That looks like an upside down omega there. And this says 1480. It looks like 1480, 1480. Could be 1480, which would be more of a part number. But it could be 1480 ohms. Because like I said, that looks like omega there. So I don't know. The micro is so bad that it took out some of the readability of the number. But right now it's measuring 28 ohms. And that would only make the difference. It's not critical. It would only make the difference between speed, high and low speed. So if it was a dead short, it would be high. So you have high, and then you have low going through this resistor. If this was a dead short, if it was 0 ohms and shorted out, you would have high and high, because that's what high is, directly to the motor. But with the resistance, you have high, and then you have less voltage because of the voltage drop across this resistor. So you have high and low speed. And the higher this resistance, the slower the low speed would be in relation to the high speed. And so if you're working on one of these fan motors, even if you don't know anything about the motor, like I don't in this particular case, I don't know much, and you don't know anything about the resistor, knowing the circuit, knowing what it's supposed to do, that helps. I can literally short these 2 wires out, and the fan would still run on both switch settings. They just run on high on both switch settings. So now if it was open, if the resistor was open and it was no resistance at all, just an open circuit, then you would have high and nothing. It just wouldn't run on the low speed because it wouldn't be getting any voltage. It'd be an open circuit. Short circuit, run on high. Open circuit, won't run at all. Any value of resistance is going to make it run slower. The amount of resistance determines how much slower. But there's also a rating, a voltage rating on the resistor. And so if they're too low of a resistor, too high of a resistor, would have more voltage across it, and if you exceed the voltage rating, you could burn out the resistor, in which case, again, low won't work. So those are things that you need to know when you're working on these fans. So for you people who follow me to learn how to do this stuff, this is what you want to look at, and I'll show you how I clean that as well once we get it out of the case. So that's the next step. I'll be back. Okay, I got the stator out of the housing, and let me get my other light over here so you can get a better shot of what's going on. Looky there. And so you see why that definitely does not help. Also, there's some wear on the wire, but the cloth wires inside are in great shape. So the head wire is fine, but I can replace the head wire and put a new line cord. I'll have to ask the customer if they want me to do that. Put a new line cord and head wire on this while I got it out. But I'm going to go ahead and clean this off, get all of this out of here, and see, and get it all cleaned out, and then see what the customer wants me to do about the line cord. He probably just wants me to go ahead and get it running. So we'll probably just do that. This cord is fine. I can put a piece of shrink wrap over that and it'll be fine. Yeah, no, I should be wearing gloves, but oh well. The way I look at it is it's safer than COVID. At least this won't kill you. I'm going to go ahead and clean all this out. I just wanted to document what it looked like. This side of the coil doesn't seem to be as bad as the other side of the coil. There's some on here. But anyway, I'm going to take this out and blow it out with the compressor. And I'm going to flake off some of this and re-shellac it, clean the housing out, and I'll be back. Okay, I got the stator pretty well clean, got the loose stuff off with just a very soft brush. This here, very soft bristle, just went around like this, and got the loose stuff off of it. And there you have it. The coil looks pretty good. So I'm going to shellac it and do both sides. So we can shellac it and it'll be a real good seal. Keep that coil cool. And we cleaned out the cases. That one and this one. The next thing is I got to break free the bushings here. This one's not too bad. It's hard to do and hold the phone, but it's hard to do and hold the camera. But you see how that turns in there? It just needs to be able to move around. Sorry for my hands and banging the camera there. But basically that just needs to be cleaned. If you have to take it out, you can, but normally these are not difficult to clean. You can just use some contact cleaner or brake fluid or anything like that, and then just dry it out really good and re-oil it. It just gets oil, it doesn't get grease, and the oil comes in through the oil hole there. So, but you can put oil in here on the rim, on the brass sleeve there, the bushing. You don't want to put a lot of oil, you don't want standing oil, you just want it oiled. And then what I do is I lubricate the shaft with the armature before I put it back into, and it should just, turn freely. This one is really dry, as you can see in there. Let's turn the light in there. See how dry that bushing is? That hadn't been getting any oil. And getting the oil port is there. When you assemble it, of course, make sure the oil port is facing up. That's common sense, but you'd be surprised. Anyway, that's where I'm at. So I'm ready to shellac this, let it dry, and then we'll reassemble it. Okay, I gave this a coat of shellac. I'm going to give it another coat, and it'll be in nice shape. And that'll help it stay clean for a good while and protect these coils from damage, from dust and debris flying through the fan, and we'll be in good shape. Then I can reassemble this. And like I say, those wires are like new in there. They're in really good shape. Just the outside of this got messed up. So I think if we just put some black heat strip across this, it should be fine, unless the owner really wants a new cloth wire. There's no sense in changing this one. I mean, it wouldn't be cloth, it would be rubber insulation, but there is cloth wire inside, so we'll see. But that's where I'm at, and then it's time to reassemble this guy back into his can. By the way, there's the shellac I use on this one. It's a good shellac, does a good job. Very thick, dries in minutes, and it's clear, and it'll do a great job. So, Zinsser, and they've been making shellac since 1849. It says right there on the can. And so, if you need to shellac anything, that's a good shellac. It's one I recommend. It's a nice thick coat. Looks like it's wet. It's not. It's dry. This is the first coat. But see, it's a nice thick coat. You can almost hear it. I was tapping on metal. It sounded like that. I can actually feel it with my fingernail. Good coat for one coat, and with two, we're going to be in great shape. Thanks for watching. If you found this video informative, please consider giving it a thumbs up, and I'll make a part 2 after I get it assembled, or I'll add to this video, one or the other. Thanks for watching.